I hope you remember what a linear system is by now. It is two or more linear equations, and the solution, what you are trying to get for your answer, is where the lines cross. Here are the three possibilities. Your two lines could cross just one time, in which case it is called consistent and independent. Your two lines might be right on top of each other, in which case there are infinitely many solutions, and it's called consistent and dependent. And lastly, your lines could not cross at all because they're parallel. That kind of solution does not exist, and it's called inconsistent. So the last way we're going to learn is solving by elimination. And we are going to eliminate either the x or the y variable. So let's just make a note. Get rid of x or y. And what we're going to look for to make sure elimination is a good choice is that our x's and y's and equal signs are all stacked up. So look at how the x's are all lined up vertically, our y's are all lined up vertically, our equal signs are all lined up, and then the number they're set equal to, those are all nice and lined up vertically. This makes it perfect to try to cancel out either the x's or the y's. And we do this by turning the equations into one big addition problem. So let me ask you this. If we add 2 plus 4, is that going to cancel out the x's? No. But if we add 3 plus negative 3, will that cancel out the y's? Yes. 3 plus negative 3 will be 0 y's. So you could write 0y, but you don't even have to do that. We're just going to cross out those 3 y's. So now, all we have left is 2x's plus 4x's, which is 6x, and 34 plus negative 4, which is 30. So let's solve it for x, and we get x equals 5. So we know the first coordinate is a 5, and now we just need the y. So we're going to take this 5, and we can plug it either right here or right here. It does not matter. I'm just going to go ahead and make it plugged into the first equation. So we're going to have 2 times 5, because we're plugging 5 in for x, plus 3y equals 34. 2 times 5 is 10. And next we will subtract that 10, which leaves us with 3y equaling 24. And when we divide by 3, we get y equals 8. So the final answer here is 5, 8. Go ahead and try the next one. And you're going to want to make sure that the x's are stacked up, which they are, the y's are stacked up, the equal signs are stacked, and the plain numbers are stacked. And then it's just up to you if when you add the equations together, if the x's will cancel out or if the y's will cancel out. So go ahead and try that. You should get -2, 5 for that answer. Alright, we're going to try the same thing with the next example. Looks like our x's are stacked up, our y's are stacked up, our equal signs, and our numbers on the other side. It's good to go. So I'm going to put the line underneath, and now we can decide which variable we're going to get rid of. Will 2 plus 5, will that go away? No. Will 1y plus 1y go away? No. So there's something we can do to fix this. If we change that plus sign to a minus sign, now will one of the variables cancel out? Yup, because 1 minus 1 will cancel out. So we're going to subtract everything in this problem now. So there's that giant minus sign out front, so let's do that. 2 minus 5 is negative 3x. Here's our equal sign, and the minus sign applies to everything, so it's going to be 12 minus 33. That gives us negative 21. So we'll divide both sides by negative 3, and x will equal positive 7. Now we can take that 7 and plug it into either x value, either that one or that one. I'm just going to go ahead and plug it into the top one. So I'll have 2 times 7 plus y equals 12. 2 times 7 is 14. We'll subtract the 14 from both sides, and we get y equals negative 2. So there's the answer. Let's check out this next one. Our x's are lined up, the y's are lined up, the equal signs are lined up, and the numbers over there are lined up. So we'll put a line underneath, and what can we do to make either the x's or y's cancel out? Well, it looks like 4x minus 4x will cancel out. So let's cross those out. Don't forget, this is a subtraction problem. So be very careful when you are subtracting. It's going to be negative 9 minus negative 5, which is basically going to turn the minus negative into a plus. So it's going to be negative 9 plus 5, because it looks like this. So negative 9 plus 5 is negative 4y. And next we'll do 26 minus 2, which is 24. So I think you can take the rest of the problem from there. You should get negative 7, negative 6 for your answer. Alright, last example. So far, example 1, we could add the equations together and a variable would cancel out. In example 2, we just had to subtract. Now let's see what happens in this problem. Looks like everything's stacked up. I have 6x and minus 2x, and I have 8y and negative 3y. It doesn't look like if we add or subtract these that anything's going to cancel out. And the reason it worked before is because I gave you two of the same number. Like if this was a 6x, I would have maybe given you a 6x there. Or if that was 8, I maybe would have given you an 8 there. If this was a 6, that would be so wonderful, because then 6 plus negative 6 would cancel out. Well, there's a way that we can make that happen. So we can't just write over top of it, but we know we want that to be a negative 6. What can you do to 2 to turn it into a 6? Well, you can multiply it by 3. If we times that by 3, then we'll have negative 6x, right? We're not going to have to change the top one, because that one's a 6x. We can turn the bottom one into a 6x, and it will be great. So I'm just going to recopy the top equation, but you can't just multiply one of the numbers by 3 on the bottom. We're going to have to multiply all the numbers by 3. So it'll be 6x, negative 3 times 3 is negative 9y, and then the other side will also be negative 9. Now we can add these two equations together. All I did was I multiplied every number on the bottom by 3. That way that negative 2 would turn into a negative 6, and we can cancel those out. So let's continue by adding the rest of the items together. 8 plus negative 9 is negative 1. 12 plus negative 9 is 3. Divide by negative 1, and we get y equals negative 3. So I'll put that right there. Now we're going to take that and plug it into any one of the y's that we want. That one, or that one. Let's plug it into this one right here, just because these numbers are smaller. So we'll have negative 2x minus 3 times negative 3, because that's what y is, equals negative 3. It's a lot of negative 3's. So we have negative 2x. Negative times negative is positive. We will need to subtract that 9. So we're going to get negative 2x equals negative 12. Divide by negative 2, and we get positive 6. So the answer here is 6, negative 3. This last problem, let's see what we could do. The x's are stacked. We have a 9 and a 2. They're both positive, so we could try making them into the same number and subtract them. But let's look at the y's. We have negative 15 and positive 3. Well, at least one of these is positive and one of them is negative, and the rest of the things line up. So we can multiply 3 by something in order to make it 15. We can multiply that 3 by 5, and then we'll be good because we'll have negative 15 and positive 15. So let's multiply everything on the bottom by 5. So the two equations you'll work with, the top one doesn't change. The bottom one will become 10x plus 15y equals negative 60, and you will be able to turn that into one big addition problem with the y's canceling out. So take it from there. And your final answer should be negative 3, negative 2. Be very careful with your negative signs. That's usually the place where people get messed up the most, so just be careful. Now all you have to do is pick your favorite method of solving. It doesn't matter to me, just pick your favorite.